What's up, peoples? Had I been in school today, we would have gone over this homework. So here it is really quick. Number two from that homework is more likely what you'll see on the test, where it's pretty straightforward in terms of astronomical units. But this is a pretty substitute and solve kind of expression. Notice that I have put in here in the numerator the thing I don't know. Strongly suggest that. So this planet is in the numerator in both the distance and the period. But basically, it ends up being, because the astronomical units divide out, it's 8 cubed, which becomes 512. And then if you square root both sides, you're going to end up with 22.6 years. And then technically you multiply 1 year over, but that doesn't matter. So that's pretty straightforward. And number three, traditionally, there's been some issues with this. We don't know anything about the satellite. So satellite is in a numerator. It has a distance r. The moon is twice as far away, so I called it 2r. The r and the r divide out. I basically cubed 1/2 and got 1/8, and then square root both sides. And once that's done, multiply the 27.3 days over times this decimal, and you get 9.65 days. Simple as that. It's a very substitute and solve kind of expression. Now your test is going to be moved to Friday, because I want to make sure I'm there to give you the test in case you have any questions. So sorry about that, but that's how it is. On your test, you'll have 9 multiple choice. I would definitely take a look at number 3 on the review for some of those relationship kind of questions. And also don't forget that constant question is going to be on there. Are you going to get it wrong? I hope not. And excuse me, 8 through 18 on the review are all gravity related. There will be no horizontal circles, vertical circles, or conical pendulums on this test. This is strictly since what we've done since the test, since that previous quiz. There'll be a Kepler's third law problem, pretty much substitute and solve. Orbit is always the same. Just got to watch kilometers and altitude and stuff like that. And then to change it up a little bit, there's going to be an equilibrium problem with gravity. And we've done equilibrium before. It just means the sum of the forces is 0. And one of the old ones we did was when we had a mass hanging from 2 strings. So if you still have that homework, it's very similar. It's just, it'll be an object in equilibrium where the forces add up to 0. So some of the forces in the x and some of the forces in the y are 0. And one of the forces acting on an object will be the force of gravity, as in gmm over r squared. And that's basically it. So you may want to go back and take a look at that. But other than that, not much else to say. With your time that you have remaining today, maybe start working on that review. All right. I'll see you soon. Bye.